Welcome back. We're going to talk about finding values when we're talking about normal distributions. Here's where we are. Check out the pen, make sure it's working. Yeah, we're there. And remember, section 5.5 is out. We've already covered 5.1, talking about the normal distribution in general, and in particular the standard normal distribution. Then we talked about how do you find probabilities. And basically that's the same thing as finding areas on your normal distribution. Now we're going to find values. What do we mean by values? Well, if you remember, up here in section 1, we were talking about z-scores. And we can get z-scores by using this formula. Take the x, which is a value that we would think of as a normal, typical value. Subtract the mean for that particular normal distribution. Divide that by the standard deviation, and we've got our z-score. This is what we're talking about, finding the x's if we don't have them yet. So we'll find z-scores, and we'll transform the z-score to an x value. And in reference to this first one, although we'll find z-scores, usually what's more important is finding the x values. So we'll find the specific data value. We're talking about x's there. Of course, you have to have a normal distribution, and you have to be given the probability if you're going to find that x that you're looking for. So, remember the z-score formula. There you go. In particular, if you had a z-score and you knew which normal distribution it was, meaning you have the mean and the standard deviation, you can find the missing part. It's simple algebra, or should be for you anyway. So we're going to find x values in this section. This is sort of a visual of what we've done. We've taken x scores, found the z-scores, and then finding the probability. Although I showed you a way to go directly from the x-score to the probability. Now what we're going to do is we're going to go in the opposite direction. If we want to, we can go from probability to a z-score, and from the z-score to an x-score. Or we can just go from the probability directly to the x-score or x value that it's associated with. So let's start off by finding the z-score that corresponds to this cumulative area. What am I going to do? Can you guess? I'm going to draw a picture first. Now we're talking about z-scores. So remember right away, you know, zero's in the middle, positive values out this way for z, negative values out this way. So this is our z-axis. Now it asks about a cumulative area of 0.3632. What does that mean? That means whoever was collecting that area or putting it together started at negative infinity and kept going until they fill it up, basically 36% of the area under the curve. So since this is 0.3632, it's not half yet, and we started from negative infinity, that means we must be somewhere in this region. And we're talking about z-scores, so we can put a z there. So how do we do that? Well, up to this point, we've been finding probabilities or areas. Now we're going the opposite direction. So you'll probably remember we were using normal CDF on the distribution menu, which you can get to by going second vars. Now, we're not doing that. We're going the opposite direction. Remember, normal CDF, again, so you don't forget, is option number 2 in the distribution menu. We're going to go instead, since we need to go in the opposite direction, which will be rather difficult with what we've got, we're going with option 3. And this is called inverse normal, because we're going in the opposite direction. So how do we get the z-score that corresponds to that cumulative area? Well, this is how you do it. You're going to go there and you're going to pick up the inverse normal function. Now the way this one works is, in general, you type in the area first and you tell it what normal distribution you're talking about. So since we're talking about z's, it's 0 and 1. For this particular one, since we want to find the z-score, we'll go to inverse normal. Remember, that's option number 3, even though it's on this side of the screen. What area are we interested in? 0.3632. So we're talking about this area in the picture up here. A little bit less than half, or a bit less than half, depending on what you think. Now we want the z-score, so the distribution we're talking about has a mean of 0 and a standard deviation of 1. And that will give us what we're looking for. So here's our picture, and this is our z-score right here. That should make sense, because in this picture we drew up here, it's not to the halfway point yet. At the halfway point, our z would be 0, but we're still over here in the negative part. So z of negative 0.35 should make sense to you. And there is our calculator work. Here's the area right here. There's our z mean. And here's our z standard deviation. Now, you might be wondering what this left is. Well, if you have a TI-83, all you need to do is put this in. You don't need that left part. Excuse me. With the TI-84 plus CE, they gave us some more options. Typically, if we're working with a TI-83 or one of the older TI-84s, it's automatically looking toward the left, because that's how the calculator typically has worked. But starting with the version CE, it allows us to look to the left if we want to, or if we want to, we can look at the right side, or we can look at the center part. So we have an option, depending on where the area is. If the area is out here, we use left. If the area is to the right, we use right. If the area is in the middle, then we use center. And there is negative 0.35 in more accuracy, or more precision actually. So let's try another one. We're going to get the z-score. So look for z equals, how do we find it? Not with normal CDF, that's going in the wrong direction. You want normal with an inverse at the beginning. You want inverse normal, same menu, it'll be option number 3. What do we need? First of all, we need the area, and as you see 10.75%, that's not what the calculator is going to look for. It's going to look for a decimal equivalent, 0.1075. So we'll type until we get the inverse normal. For the area, we'll put let's put a 0 in there so you can see it for sure. 1075. We want the z-score. So its mean is 0, its standard deviation is 1, and that's going to give it to us. And that's what it should look like. Let me clean this up real quickly. Where's my cursor? Cursor's trying to hide. There we go. There you go. Nice and clean. There's our area, and there at the bottom is the z-score that corresponds to this area on the right. Let's try another one. Well, this looks weird, doesn't it? Well, we've talked about percentiles in the past. The one thing to remember is the percentiles, again, start from the left. In other words, if we're talking about the 17th percentile, that means we're talking about the position where 17% of the things or people are less than that particular point. So in this one, we're talking about 5% or less than this particular place. What am I going to do? Well, I'm going to draw a picture. Remember, it always starts from the left, unless we're using a CE, of course. So this represents 5%, which represents 0.05 as a decimal. So starting from the left, that means in here, we've got an area of 0.05 or probability of 0.05. So there's our picture. And we're going to find what that z is. Again, we're looking for a value, whether it's a z value or an x value, this time a z. So we're going to go back to inverse normal again, because we're working in the opposite direction. We put the area first, 0.05. That's not much of an area considering the whole thing is 1. We want a z-score, so 0 and 1 goes there. And here's our z-score. The one we get from using inverse normal with 0.05 for an area, 0 and 1 to tell us we're working with z's. And that's what your calculator should look like. And for you CE people, calculators speak wise, we're talking about the area that's on the left. So if you've got a CE, the 0.05 is the area on the left, so you make sure you put the left in there instead of the center or the right. There's our answer, and a little bit more precision. So this should set you up for the next one. I'm going to draw a picture, and I notice it's the 50th percentile. That means halfway. So in this one, we're going from this point, negative infinity, up to the middle point, the axis of symmetry. Remember that? So the area that we're talking about is 0.5 0, 0, 0. The area and here. And since we're looking for a z-score, a value, we're going to use inverse normal, inverse norm to the calculator. We'll put 0.50 in here, a couple of more zeros if you want to, that's up to you. We want the z-score, so this is the curve we're talking about. Here's the picture. Here's how you put in the calculator. If you've got a TI-83 or an older TI-84, you don't need the left because it assumes it's from the left. And of course, the z-score is 0 because in a z distribution, 0 is right in the center. 0 standard deviations away from the mean. Now, I hope you've gotten this one, so please hit the pause button and try this one yourself. You should be able to do it. And I'm going to show you 2 ways that you can do it, just to help you be a little bit more clever when it comes to this. So first of all, picture, it's 90%. That's almost the entire area. So we're going to go all the way over there. This is 90% there, which corresponds to the 90 you see with the percentile. We want a z-score or z-value. So to get that, we use inverse norm. The area, as you can see here, is going to be 0.90 out of the 1. We want a z-score, so it's going to be 0 and 1 here. And just for your information, although I think it's dangerous information, if you don't put the 0 and 1 there, it's going to put it there for you. But it's safer to, as a habit, put the mean and the standard deviation in there. So I have an area of 0.90, which means a probability of 0.90. There's our entry, and the left for you CE people, and there's our value. Now in the picture up here, if you look back here, notice that this is in the this particular spot is on the positive side. And as you can see down here, sure enough, we've got a z value that's a positive 1.28155, etc. Now, I mentioned this a little bit earlier. If you take this and solve it for z, well, maybe you want me to do that. So how can we change a z-score to an x-score? Where did this come from? Well, remember, you want to remember this, of course. X minus mu over the standard deviation is how you find the z-score. So if you have the z-score and you want x instead, first of all, as an algebra student, you'll multiply both sides by the standard deviation. That'll give you z sigma equals x minus mu. But what we want is x. So we'll add the mu to both sides, and we'll have x equals mu plus z sigma. And that's what we've got indeed. Now let's play with this a little bit. So the veterinarian records weights of cats, and the weights are normally distributed. It better be, because that's what we're working with in this chapter. You've got a mean of 9 pounds, so I'm going to put that in. So we've got a mean equals 9 pounds. And standard deviation, need that too, 2 pounds. Now, what we've got here is z equals 1.96. So let's start with this. Z equals 1.96. But we want x. How do we find x? Well, up here, we take the mean and add the z-score times the standard deviation. So just fill in the blanks. X we don't know yet. The mean up here is 9, so put a 9 in there. The z-score was 1.96, and the standard deviation was 2. Job for the calculator. In fact, if your calculator was broken, you could still do this. Multiplying 2 times 1.96, adding 9 to that will give you your x value. How would we do the second one? Same type of deal. We have z equals mu plus, I'm looking for x, right? X equals mu plus z standard deviation. This x equals, you've still got the mean of 9. For this z, you've got negative 0.44. I might put that in parentheses so we know exactly what it is. And our standard deviation is 2. Take the calculator to that, you've got your answer. Now, what I really wanted to get to was this third one, because you could actually do this in your head. You don't think so? Take a look at this. Here's our equation readjusted so that it's solved for x. Mu plus z standard deviation. And the z is 0. So, since this is 0, well, mu equals x, or just 9. Isn't that interesting? Well, if we draw a picture for this, remember, drawing a picture is really handy. For our normally distributed weights, we've got 9 in the center, and the standard deviation is 2 both ways. Remember though, if we were talking about z-scores, right in the center is 0, which means our x value will be 9, because that's the center of our x-looking normal distribution. So you should be able to look at this and say, oh, that doesn't vary at all from the mean. Since the mean is 9 pounds, z of 0 means 9 pounds, period. If you look at this one back here, this says we're going to the left, so it's less than 9 pounds. This one says we're going to the right of 9 pounds. There's our formula again. And there's our first calculation. Remember, we had a z-score of 1.96, so it should be more than 9, and when you finish it up, you got 12.92 pounds. For the second one, we're going the other direction, so we should have less than 9 pounds, and there you are, 8.12 pounds. And the third one, you know, is 9 pounds, because there is no variation from the mean. Got that? So here's a summary of what we're talking about. Here's our 9 pounds as mean. To the left will be lower than that, smaller than that. Z-wise, it's negative values. To the right, it's heavier in weight, and z-score wise, it's in the positive direction. You might want to keep this in mind and think of it while you're drawing your picture. The x value here will be at the mean, and the z value in the middle is always 0, with positives in this direction, negatives in that direction. Okay, let's try something with some real numbers. We'll talk about the California Peace Officer Standards and Training. So they have to take a test to see whether they're going to be accepted into the training. Well, look at the second line, and it says mean. Let's put it here. Mean, oops, better again. Mean is 50, and that's just points. And the standard deviation is 10. We want to know the lowest score you can earn and still be eligible. What do you have to earn? You have to get in the top 90%. Okay, are you confused? Draw a picture. Where's the top 10%? Top 10% is up here. What does that mean? You've got an area up here of 0.10. What's the area in the rest of it? Well, the area in the whole thing is 1, so the area here is 0.90. Now here are two ways of doing it, depending on your calculator. If you've got the CE version, that means you can tell the calculator where that area is. In this case, the area is on the right. We've got the top 10% of the people who are going to be entered into that training if they want. So the way you're going to do it, we want a value, an X value in this case. So you're going to go to the distribution menu, pick up inverse normal. Remember, that's option number 3 on that menu. First of all, you put in the area. Now, if you're working with a CE, you can put in the area straight away. Just 0.10. That's the 10% that are in the top. What else do we need? Well, we're talking about the, let's see, you want the lowest score, so you want the X value. So we don't put 0 and 1 out here. We're talking about the real curve. Mean, 50, because we're not talking about Z's. We're talking about regular scores. Standard deviation, 10. Now, if you've got the CE, this is only for CE. Since it's on the right, you'll put right here. And the calculator knows, okay, area 0.10, this is the normal curve we're talking about, and the area is on the right, and that'll give it to you. Now, what if you don't have a CE? A regular TI-83 or TI-84. Okay, we're going to have to be a little bit tricky. Remember that the TI-83s and earlier 84s always are talking about the left-hand side. So for you folks, you still go to inverse normal in the distribution menu, but what you need to do is you need to put in 0.90 and then 50 and 10, and that'll give you your result. There is one other way of doing it too. I don't want to confuse you, but just in case this hits you, right? Since this is 0.10, and that's not really what you want, what you can do is inverse norm, and what you might want to do is put 1 minus 0.10 because you're talking about what's left. We're talking about this one for the TI-83s and older 84s, and you still put in the 50 and the 10 because you want the actual value, not a z-score. So let's see, let's give you a better picture here. Clean this up. There we go. So there's our top 10%, but it's on the right. So we have to be clever about this. Remember, 50 is the middle score, and if we're going to get in the California Peace Officers training, we're going to have to be better than 50%. We've got to be better than 90% of the people applying. Z-score wise, that means a Z-score is positive. We don't need to use that for our inverse normal though. So we want the Z-score that corresponds to an upper area of 0.10. And I don't have this on this screen. Interesting. Well, come to class. If you haven't figured it out, come to class and see if you can get it. If you really want to know whether you got it right or not, send me an email. I'll let you know whether you're right or not. Now remember, it's going to be over 5 or 50, over 50, and we're expecting maybe a 60, 70, maybe even 80. See what you get. This time you don't need to pause, because I'm not going to show it to you right away. Okay. Now this time we're looking for a specific data value. That means we're looking, this is an eyeball, we're looking for the X for this particular example. All right, so we're talking about US adults 20 and over. That's our population. The mean, see, I better put it over here so it's out of the way. The mean is 190 milligrams per deciliter. And the standard deviation is 40.9 milligrams per deciliter. What's the highest cholesterol you can have and still be in the bottom 1%? What do you think I'm going to do? Well, I've got all the data here. I need a picture, don't I? Where is the bottom 1%? Bottom 1% is going to be back here. Not much area to that. 0.01 is the area back here. Notice it's on the left. And I want to find out what this cholesterol level is going to be. X value for the cholesterol. Well, we want inverse normal, don't we? So I'm going to get inverse normal. I've got an area, notice it's on the left, so all of us could put 0.01 there for 1%. But these aren't Z-scores, these are X scores we're working with. And the mean for this one, we already know from over here, is 190. The standard deviation is 40.9. Notice that regardless of what we put in, we don't have to worry about our examples having nice even numbers anymore. And that will give us our area. And what do you think you're going to get? Well, certainly, if the mean here is at 190, we expect our cholesterol level to be way below 190. There's our picture, a little bit better. If you were using tables, you probably would want this Z-score. And you could use inverse normal with that Z-score, but we don't need to. The area is 0.01, and there's our inverse normal, there's the area, there's the mean, there's the standard deviation. If you're using the CE, then inverse normal still, 0.01, 190, 40.9, and we don't have to worry about whether it's on the right or left. You can just put in left and it's going to work the problem exactly the way we want. That means for that cholesterol level, it would be about 94.7 to be in the bottom 1%.